Hey everyone, welcome to another session of Chaos Carnival. We have with us Yury Niño Roa. She's a DevOps engineer at ABL Digital Labs. She's a software engineer with 6+ years of experience designing, implementing, and managing the development of software applications using agile methodologies. She also has 2+ years of hands-on experience supporting automating and optimizing mission-critical deployments, leveraging configuration management, CI/CD, and DevOps processes. Hey Yuri, thank you for joining.
Hi. Hi, Mohan. Nice to meet you. Thank you. Thank you very much. So, let me know if I have to wait for the video. I thought that's all.
No, I mean you can share your screen and get started with your session.
Okay, so can I share my screen? Okay, thank you. Thank you very much. The title of my talk is Tulp, Integrating Artificial Intelligence and Chaos Engineering to Learn from Incidents. So nice to meet you. I am Yury Niño. I work as site reliability engineer in ADL Digital Labs, a company in Colombia that provides technology and innovation services. At this moment, I am performing a role as technical program manager in this company. So I am from Colombia, although I am presenting from Bogota. I was born in Garagoa, Boyacá. Garagoa is a beautiful and small town in Colombia. So you are welcome in Garagoa. You can find me in Twitter, LinkedIn, and Medium as Yury Niño, and this is my personal webpage, Yury Niño at Depth. So let me, before starting, I would like to share this phrase from Rob Shep, who is the author of this book, Incident Management for Operation. That is a really good book if you have the opportunity to review them. So I recommend. So let me start with them. Okay. I'm having some issues here, but yeah. So incidents are not concerned about making a quick decisions. Incidents are about to make the best decision in the shortest amount of time. Time is the most important commodity that exists. That is a phrase that I would like to start this talk. So this is the agenda for today. First, I am going to share a story about Tulp, an old painting on canvas by Rembrandt. So from this story, I am going to review some patterns or anti-patterns that we identified while I was analyzing several postmortems. With this context, I am going to introduce some concepts related to machine learning. And finally, I will join these points. I will join point-related incidents, postmortems, and machine learning in order to provide a proper solution to a problem that I am going to describe after. So the idea is to show the value of breaking things on purpose with a novel discipline known chaos engineering. So let me start with the story. So another lesson of Dr. Nicholas Tulp is one of Rembrandt's most famous painting. It was painted in 1632, and it depicts what was one of the hot scientific topics of the time, anatomy. So what makes the painting interesting? It does is explores the relation between art and anatomy. So Nicholas Tulp was famous for being both a surgeon and the mayor of Amsterdam. Tulp gave annual anatomy lessons in the winter time, so using the bodies of people who had been public hand. So probably many of you are thinking, why am I talking about a medical book? The reason is that Tulp books are a compilation of postmortems, so which is the main topic for today. That is the reason that I am speaking about Tulp, about his books. So medical information book has minute description of Tulp's work, including 231 quizzes of disease and death. Some call it the Book of Monsters because Tulp dissected animals brought back from a company in India. So, but also because of the fantastic stories documented in Postmortems. So that is the reason for talking about these books. Is related to background to Tulp, who performed as surgeon in the past. So let me share the proper topic for today. And we are starting with the first point for today, incidents. Incidents are inevitable. So a definition for incidents is incidents are occurrences, either human cause or natural phenomenon that requires action or support emergency services personnel to prevent or minimize loss of life or damage. This definition was provided by the National Fire Protection Association. It has a short definition. It is an unplanned interruption to an IT service or reduction in the quality. So as you read this sentence, IT incidents are happening all over the world. So the response to those incidents come in many forms, from one person working on an issue or a group of people dealing into a conference. So it is the book that I was talking in the previous slide related to incident management for operation. I am taking a lot of phrases or sentences in the next slides from this book. That is a good recommendation for you. So in 1970, a series of devastating wildfires happened across California. So destroying more than 700 homes, over 775 square miles in 13 days with 13 fatalities, and resulting in more than 233 million in losses. So thousand of firefighters from around the states and beyond respond, but found it very difficult to work together. So they knew how to solve firefighters, but lacked a common management framework that could scale up or down with the incident. They also lack a standardized approach for incident leadership. So several fire service leaders created revolutionary systems for managing emergencies that today is used by firefighters and medical emergency teams. The incident command system was born, the ICS, which has since evolved into the incident management system. In the next slide, I am going to share how people involved in IT services adopt this framework in order to have a map to manage incidents in our systems. So this framework was adopted by incident management in IT. That is the story related to the incident management system. And according to Slack, there are different stages for incident management. The cycle starts declaring an incident. And here we can use automated alerts and internal and external notifications. Next one is containment. Containment is about determining the responsible for driving a particular incident to resolution based on the incident source, type, and priority. In the transit of containment and remediation, the idea is to create communication channels. Is key to prevent, so it prevents the creation of silos, for example. And finally, as part of analyze and learning, we have a lot of activities that I can run or that we can run. So this part is related with postmortem. So that is really important part after the incident. So another part related to this framework is the preparation. It's really important to have the opportunity to prepare our engineering teams before an incident, because probably you think in incident when the incident is happening, but it's our responsibility as leaders, as software engineers and SREs and DevOps engineers to have time or to dedicate time to prepare an incident management, because when you prepare for them, it's easier to face the failure in the incident. So I was talking about the analysis and learning. So in this part, it's important to have the opportunity to create an incident document, for example, which is known as postmortem, engage individual resources, orient individual resources, notify key stakeholders. Is very important. For example, business people and product people and the other roles that works with us is notified about the incident. So drive incident to a resolution, and finally perform postmortem. That is the idea of this part. So that is a focus for this presentation. So it is the framework explained by Slack. This slide is from Slack, so it's important to clarify that. So metrics that we have in an incident management is related to metrics, or is about metrics. That is the theory says about the incident management. So we have a lot of metrics because managers and product managers, for example, love metrics and love measure the engineering teams. So we have these metrics in order to have a possibility to measure what is our performance for managing an incident. So the first one is time to first response, or TTFR, which is measured during detection and alerting. Time to resolution, on TTR, which is measured during containment and remediation. Incident mean time to repair, MTTR, which is measured in the end during the incident. And incident volumes, that refers to the number of incidents, and percent of incidents resolved with SLAs. So as you know, SLAs refers time and commitments responding by a change or an incident. But I would like to share that during my career, I have identified incident management is about persons, it's about people. It is about metrics, that is a fact, but it is about persons, it is about people. So the process, because the process in incident management is about how your organization discovered an issue. So in this part is really important, for example, answer questions such as how it dispatches the responders, how the commanders organize the responders, how those responders, people, engage in the resolution effort, how escalation happens when more or different experts are needed, how to control the communication channel, how people control or manage pressure, emotion, motivation when they are facing an incident management. So in my experience, so my conclusion is incident management is about people also. No, not just is incident about metrics. Considering this, I would like to share these roles involved in managing an incident. Incident commander in this part. Incident commander, who is the leader of the incident response. He is responsible for focusing the group, developing incident objectives, providing direction and time management. In the other side, we have a group leader. His job function is created by the incident commander. He's another leader in this situation. Basically, he leads a group of subject matter experts. I am going to talk about them in one moment, from similar functions. For example, if we have DBAs responding for the incident, the group leader is one DBA as the DBA group leader. So situational status here, also known as described in another framework. He is described. He is the person who records all information related to the incident, and he has the responsibility to keep in track the situational status, updating technical debrief or the other form on incident documentation. So plans group is a group established by incident commander, who is the leader, who with the responsibility this team is committed with a subject matter expert in order to provide alternatives for solving the issue. So his mission is probably is confusion, but he works as a plan B in order to have a support for a subject matter expert. And finally, subject matter expert, they are the technical expert. They are he is solving the issues. He is solving the incident. So this job function is the technical experts supporting and working with the incident commander in order to solve the issue. Subject matter experts vary from the company to company, considering that probably you need different expertise in different incident management. For example, if you are facing an incident related to database, the idea is subject matter experts have knowledge about databases. So with this context related to incident management, what is an incident, what happens in an incident, and share my personal position related to the incident management is about persons. I would like to move to another side of this presentation. It is related with the patterns, or better, anti-patterns in the middle of the chaos. With the idea in this part is to provide some sad stories, managing incidents, and identify patterns in order to provide after that a proper model, a proper map to propose a solution using artificial intelligence. As you know, artificial intelligence is about supervised and unsupervised algorithms in order to provide a solution for anything. So the idea in this part is provide the categories or the classes for having a model to manage this part. So the famous ARPANET network created by United States Department of Defense had a lot of challenge during a dark period. One of those episodes happened in 1980, when for several hours it left without service because there was an error in the interface. Message processor corrupt routing data. So the software recalculated checksums explaining corrupted data, and incorrect sequence numbers caused the buffers fill up, so leading to package loss and eventual node removal. So that is the first sad story. That is another story, but serves as context for our first pattern. On June 4, at 10:25 p.m., a power loss in one AWS data centers in Sydney associated to a natural incident caused the outage of a significant number of cases in an availability zone. As if it were an scene from a horror movie, all circuit breakers failed on the power backup units, resulting in a degraded power loss on degraded power grid. So this fact reminds us that we can never promise 100% in ASLA. So on January, at 23 a.m., the primary data centers in GitHub experienced a brief outage in the system supplying power to servers and equipment. Just over 25% of the servers and several network devices were rebooted as a result. Although the load balancers and large numbers of their front-end application servers were unaffected, backends they depended to the services. So in response, the application delivered a lot of HTTP 500 response codes, which carry the Unicode, the GitHub to an outage. So what is common here in these three sad stories? It is the first, our anti-pattern, power failures. It is common here. So it is the first class for our model in the artificial model. I am going to explore in one slide. So in some slides, sorry. So that is common here, power failures. So I am going to move to another type of incidents. I am talking about this outage for Stack Overflow. On August 25, 2014, Stack Overflow was down for 6 minutes the cause was an incorrect change in the network firewall configuration. Specifically, it was in what IP tables were being used by the proxy load balancers. The change has had the effect of preventing to able to complete the connection to the IIS web service to respond traffic to these connections was suddenly being blocked. The IP tables configuration is managed by Puppet and stored in Git. After pass change to GitHub, the load balancers apply the change and they Puppet run again. So that is the first story. The second story related to this second pattern, again GitHub, but now with configuration errors. During 3 months, on average every 2 weeks, they received reports of failures in the platform for hosting and deployment of applications. This was a dark period for GitHub in the last year. So on July 17, a configuration error caused an outage for Cloudflare Internet Properties and Services that lasted 27 minutes. So traffic dropped by 50% across the entire network. Due to the backbone architecture, this outage didn't affect the entire Cloudflare network and was located to certain geographies. But the error here was related to a configuration error. So what is common here? It is the second anti-pattern, and it is related to the configuration files, to the server errors, to the errors related to, or as consequence of a bad configuration or about bad text or bad property in a configuration file. That is the second part. So finally, I would like to share this third pattern related to the security issues. Here are the most famous computer viruses of all time. Probably many of you remember CryptoLocker or I Love You. That sounds like a cheerful you might find print inside a Valentine Day card, but actually far more sinister than that. I Love You is one of the most well-known and destructive viruses of all time. So here there are another viruses, for example, MyDoom, Stuxnet, or I Love You or CryptoLocker. So according to several experts, NotPetya is the most devastating cyber attack in history. NotPetya was a cyber attack that affected all business units. All business units and Mexline. Mexline is the world's biggest shipping company in the world. They handle around 25% of all containers shipped in Asia and Europe. The story of this tragedy started with a message, repairing file system in C, and a strong warning not to turn the computer. So NotPetya was based in a virus with a piece of criminal code that stored victims to pay for a key unlocks their files. So that is here, or that is common here. I have more time. So what is common here? The pattern here is related to security vulnerabilities in software. So as you notice, if we have vulnerabilities in our systems, we have susceptible to be a victim of hackers. So that is our last pattern. In this part, we review 3 patterns. Pattern or postmortems, or better incidents related to configuration files, related to security issues, and related to power failures. So as exploring these postmortems in the web in order to build the machine learning model, we identified another patterns. I am talking about hardware issues, configuration errors, security vulnerabilities, as has mentioned, hitting limits, conflicts, out of sync times, slowness, and automation interactions. So they are related to incidents and they are common in the incidents. But I would like to share, although we identified issues, identify classes or categories in these postmortems, each outage is unique. The anti-patterns we perceive and determined by the stories we like, but probably we know or we have the possibility to identify someone, some part that is common in there. But it is important to clarify that each outage is unique. So each outage, but there are anti-patterns, and sometimes we can use those to create defenses. But it is really important to know that each outage is unique because, as an example, you have different people attending or solving the issue or solving the incident, which is different for each case. So now I am going to move to another concept, postmortem. I was reviewing incidents. I was reviewing patterns in these incidents, considering even attacks, cyber attacks. And now is the time to documenting chaos on postmortems. Let me start by defining what is a postmortem. Betsy Bayer, Klaus Jones, Jennifer Pitoff, and Niall Murphy, inside Reliability Engineering book, define postmortems as a written record of an incident. It is impact and the actions taken to mitigate and prevent it. According to Pager Dari, a postmortem is an artifact with a detailed description of exactly what went wrong in an incident. So, however, there is definition what I like more, and it is asking ourselves these questions: what went wrong, and how to we learn from it. So, in conclusion, a postmortem is the central document responsible for containing update incident information, including a description of the incident, links to resources, raw notes from in-person meetings, of open questions, action items, and timeline information. But it's really important to know, or really important to notice, that a postmortem we have a lot of templates for running postmortems, but considering each type of incident is different, we should have different postmortems. That is our point here. So let me mention benefits of writing postmortems. When you write postmortems, you have a possibility to have a collaborative process that allows everyone to contribute, that they learn and build resilience, an opportunity to rebuilding confidence in people who were closely involved in the incident, and a strategy to partners, customers, and end users to know what happened and what steps will be taken to improve. That part is related to the scribe mission, or scriber, who has the mission to notify to the organization about the incident. So postmortems provide a possibility to share this knowledge, these learnings related to the incident to these people, because that is a document that provides a possibility to understand it for them. So conducting a postmortem is an expensive and highly time-consuming task. Probably many software engineers or software developers don't like to write postmortems, don't like to write postmortems because it is expensive. It consumes time, so that is a really difficult task. So although also considering that is activity for after the incident, probably you are tired, you don't like to write a document after the emotion solving the incident. So that is really difficult to promote a culture based on postmortems. But looking up to automate these exhaustive works using anti-patterns identified after reviewing a compilation of classical postmortem. That is our proposal. In the first one, propose that to have different postmortem, a postmortem for each situation, for each type situation. For example, a postmortem for managing an incident related to security should be different and postmortem for managing an incident related to power laws. So let me move now to machine learning concepts. machine learning in the middle of the chaos. So machine learning is a process. This definition was taken this really good book, Machine Learning Design Patterns. Machine learning is a process of building models that learn from data. Machine learning models are algorithms that learn patterns from data. That is a first definition that provided this book. So a second definition, in order to provide a context about the next topic, machine learning is a research field at the intersection of statistics, artificial intelligence, and computer science for extracting knowledge from data. So this definition was taken from Introduction to Machine Learning with Python. That is a really good book. If you enjoy, for example, programming models or writing code for solving issues or challenge related to machine learning, that is a proper book. In order to Python is a good programming language for managing this challenge. So now I would like to share this conceptual map that classify two strategies for machine learning: supervised machine learning and unsupervised machine learning. The first one category is related to algorithms that provide a solution for when we have a class or a defined class. So supervised learning defines problems where you know the ground truth label for your data in advance. You feed this label data to your model. It hopes that it can learn enough to label new examples. Some algorithms included in this class is support vector machines, includes support vector machines, decision trees, and networks. In the other side, with unsupervised machine learning, you don't know what labels for your data in advance. So the goal is to build a model that can find natural grouping for your data, called clustering. So compare the information context or find association rules. Some algorithms included in this class: clustering, associative rule learning, and dimensionally reduction. So, with this context, I would like to share this phrase: failures are an inevitable part of making software products and services. However, it is not necessary to repeat the mistakes of the past. So, as I mentioned, with machine learning, we can learn about the past, about the data generated by past incidents. So, it is our point here. So, with this context, with these points, again, incidents, postmortems, patterns, and machine learning, I would like to share a tool we are designing in my company. I am leading a research group for exploring solutions and for exploring ways to improve our knowledge about chaos engineering. So I would like to share the design for this problem, to have the possibility to learn about the past postmortems in order to provide a pre-template for managing a new incident and train engineers, because as I mentioned, it's really important to train the people for managing incidents. So this part focus on that prediction beyond chaos. Because each postmortem template is a unique story that is difficult to automate. So as you see, in our first classification was a manual activity. Even for us humans, it requires to review, analyze, process, and make decisions to classify postmortems. For example, when I was reviewing what happened with Nopitia, I have to explore the incident. I had to analyze the situation. I had to provide the mechanisms, the methods in order to classify this. And it was a manual activity. So the idea in this part is to automate this part. So to classify postmortems and get value of the past information. Our proposal is that each postmortem should be different, but we can use some parts in order to identify classes and in order to have the possibility to use the unsupervised algorithms. In this part, it's really important to know this. There is a problem for unsupervised class for machine learning. So Tulp, it is Tulp. Tulp, I would like to introduce Tulp. Tulp is a tool that we are designing in a group of research and development that I lead in my company. So Tulp is based on the public postmortems published on internet. The idea is to use a crawler in order to build a data set with this information. So this is the problem on supervised machine learning. So we have to use clustering in order to identify, for example, use clustering, or you can use another algorithm of this class in order to identify the classes to map each postmortem. With this information, we must to implement a machine learning pipeline that learns about this data and provides a classification model in order to have a model that when we are facing a new incident, we have a pre-template for the postmortem, and we have the possibility to learn the past in a focus group of the postmortem, because in the universe of postmortem we have a lot of postmortem. For example, in my company we have 2 years in the market, but we have hundreds of postmortem. So the idea is to have a class or a focus of postmortems using this solution. So that was our first approximation, our first solution in order to solve this challenge. But I would like to share some mechanisms of strategies provided by AWS, for example, in order to solve this problem, because AWS offers the possibility to have the data set and pass them the solution and to have classes. So that is, in this part, is really important to clarify that with AWS we have to build the models, or we have to build to write code, for example. So there are several solutions provided by Amazon, provided by AWS, in order to solve machine learning issues. So at this moment we are exploring this solution: Amazon SageMaker, AWS DeepLens, Amazon Machine Learning Solutions, Amazon MRE Spark. Spark is a really good tool or technology for solving these issues or challenge. Amazon Mechanical Turk. So it is a flow provided by AWS in order to solve issues related to machine learning. The idea is to have a business problems. Our business problem is related to classify postmortems, which are unstructured text. So machine learning problem framing, the idea after that is data collection, data integration, data preparation, data visualization, and analysis. And in order to use, for example, features engineering, as I mentioned in the first one, a proposal. So with this information, we can use feature engineering in order to build a model trainer or a parameter tuning for building a model that allows to classify the information. So the idea after that is to have the possibility to visualize this information, or to have a model that provides an automated way to solve problems. So finally, I would like to share our focus at this moment is related with Amazon SageMaker. The idea is to train data, build model artifacts, training algorithms with this context, inference engine, and use Amazon SageMaker in order to build the model. So as I mentioned, that is a proposal, that is a design. We are working in learning about machine learning because, for example, at this moment it is not our domain, but we are learning about it and providing a solution for that, and provided ideas to manage incidents, to manage postmortems, and to create a culture in an organization based on postmortems. I would like to share that it's really important to give the proper position for postmortems, because in some companies the postmortems are not important, and it is really important to learn about the past incidents. And if we have a possibility to automate this activity, that is great. So finally, I would like to share two sentences. Time is the one resource you can never get back. So time can't be created. It can only be saved or wasted. So it is really important to save our time, because we need time for our families, for our friends, for our relationships. So it is really important to have a possibility to automate the task we have to run when we are managing incidents. Considering also that is a really crazy activity and really excited activity. So finally, I would like to share again. It is a proper definition I like to share, because it is related to chaos engineering. In order to chaos engineering is the discipline of experimenting failures in production in order to reveal their weakness and to build confidence in the resilience capability. Resilience is related to four concepts: actual, factual, potential, and critical. And these parts, resilience, or these concepts related to resilience, is related to learning, related to learn about the past. So that is the relation with chaos engineering, to have a possibility to manage the chaos in the incident with learning, with postmortems. And if we can automate in this part, that is great. So finally, chaos adds complexity and frustration, but more importantly, adds unnecessary time to the incident resolution. TTFR, TTR, and MTTR are putting the company's business via their metrics. So considering in the other side that the metrics are important, but the most important is people. So finally, that is all. Let me know if you have questions, but they are my contact data. If you want to learn more about chaos engineering and learn more about postmortems, we are open to hear about your proposal or about your ideas. So thank you very much. That is all. Thank you for being here. So that is all, Mohan. Thank you.
Thank you. Thank you,
My
Yury.
apologies if I took more time.
No, we are right on the dot. It's 4:01 a.m.
Okay.
We can probably take the questions to the Slack channel. We have a dedicated Slack channel for the session, and we can take those questions offline, or feel free to use the tables in the launch to talk to Yury. And yeah.
Thank you. Thank you very much. Thank you very much, everyone, for attending, and thank you very much, Mohan, for this great opportunity for us. Thank you.
Thank you. Thank you.
Bye. Have a good time.